This lesson is going to be on the third type of rocks, metamorphic rocks. Our definition is metamorphic rocks are going to be rocks that are changed by heat and pressure. And there's going to be two types of metamorphism we need to learn about. One is regional metamorphism. And regional metamorphism is when a large area or region of rock is changed by the heat and pressure deep underground. The second type is not over large regions, much smaller scale. It is contact metamorphism, and this happens when rock is changed by contact with magma or lava. So an example of that is right here. If you look at the key, the little flat lines is shale. So what this picture is of is this. This is a tree here. All right, so this right here is the surface of the earth, and then we're looking at the layers of rock below the earth. The shale is those lines, so this right here is a layer of shale. Below it, the little dots stands for sandstone. So this is a layer of sandstone. And then below that is a layer of limestone. So those are three different types of sedimentary rocks, layers of them beneath the earth. And then right in here, there's magma that's melting its way up through those rocks. And right where they make contact, right along the edges here, is where you're going to get contact metamorphism. So what you'll see on one of these diagrams is you'll have a magma intrusion like this, and it'll show little lines showing where that contact metamorphism is. So the difference is regional metamorphism is over a large scale, and contact metamorphism is just the rocks that come in contact with the lava or the magma. Top of the next page, we're going to talk about identifying different igneous rocks. And the first thing we're going to look for is foliation, or if it's foliated. Foliation is when the minerals begin to line up in layers or bands. And there are four of these. The first one we're going to talk about is slate. And slate is low-grade metamorphism of shale. If I give it more heat and more pressure, it's going to be metamorphized further or changed farther, and then it can be called phyllite. And this starts to look shiny because of mica crystals. If I metamorphosize it more and put it under more heat or pressure, it becomes what's called schist. And then the layers begin to look like plates. Okay? They're very distinct layers. And then the last one is gneiss, and gneiss shows banding. Okay, I tell my students it looks like zebra stripes. So not just layers, there are actually bands of minerals. If you were to see it, it would look maybe something like this. Here's a sample of it, and you would have these dark bands going through the rock. And that's a pretty one to easy to identify when you see that. And we'll make a note over here that there is increasing heat and pressure. So there's more metamorphism as we go down on that chart. Now, you don't have to necessarily memorize all of this. Again, it's on the reference tables just like our other rock information was. Our foliated ones are up here toward the top. Okay, the minerals are somewhat aligned or even banding. Okay, it talks about it's regional, so over a large area, there's more heat and pressure as I go down this way. And it gives comments or the information that we're putting on the chart right here. So if you know where this is, there's less memorization that you need to do. All right. Now going back. Okay. If they're not metamorphic, they're going to kind of look like the rock that they came from. So anthracitic coal is just metamorphism of coal. Next one, hornfells. It could be metamorphism of various rocks. Quartzite, there's a lot of quartz in sandstone. So this is metamorphism of sandstone. Okay, the next one down is marble. That's metamorphism of limestone. Or dolostone. If it's limestone, it's going to have calcite in it, so it might fizz in acid. And the last one's metaconglomerate is metamorphism of conglomerate. Now, these are all going to look similar to the rock they came from, but because they've been squeezed under pressure, they might be a little bit harder. Okay, so first example. We have a metamorphic rock that shows some foliation, but its layers do not look very clear, and it looks shiny. What is the rock? So our hint here is that it's foliated, and it looks shiny. So if I look on the reference table, here. I see it's foliated, so I know if it's foliated, it's going to be in the top half here. All right. And then it says it looks shiny, okay, but it doesn't show really, it doesn't show the plates. So we're going to call that one, this right here, this phyllate. All right, so we're going to go back. We're going to say that this is phyllate. Top of the next page, we have another example. It says what rocks are most likely to form at locations A and B. So at A and B, A is right here. Okay. A. We'll look at that. Well, what type of layer is it in? It's in a layer of sandstone. Right here, this is sandstone. Okay? And what do we get when magma comes in contact with the sandstone? It's going to create metamorphic rock, and the metamorphic rock that's made out of sandstone, if we look at our reference table, is right here. Metamorphism of sandstone is quartzite. So we're going to call that one quartzite. So we're going to say A is quartzite. Then for B, B is right here. Now we have these, the layer that looks like a bunch of bricks, so that's limestone. So the limestone is coming in contact with the magma, so that's being undergoing metamorphism. And if I look at the table, if I have limestone undergoing metamorphism, it becomes marble. So I know that rock is going to be marble. We'll go down here and we'll say that B is